getting inside of cells and looking at enzymes and looking at all these kinds of things that go on, which we were wanting to do. It turned out every time we looked for an explanation of how it worked in a mechanistic way, we found an explanation. And this is just a list. And for most of you, you won't know what all this stuff is, but it was really a lot of research. And what we found was that when these animals are consuming 20% protein, in a sense, everything went to hell in a handbasket, in a biochemical sense inside of the cell. You know, all these different reactions were sort of operating in tandem, in synergy, as a symphony, and creating this response. So this wasn't a happenstance thing. So I really became convinced, obviously, casein can grow cancers. No question about it. And I have to tell you, I could have said it then, I can say it today. I know a lot about how we decide which chemicals cause cancer and which don't. They're called carcinogens, you may know. I know that program. We spend $500 million a year on doing those kind of studies to see which kind of chemicals cause cancer, which ones don't. I will tell you, on the basis of this work, and knowing that program, knowing the criteria, that the most relevant carcinogen we consume is casein, bar none. In a sense, at least, that the levels we are consuming are those levels where we might expect to see a response. Unlike, the testing of other chemicals, which are often tested at, orders of magnitude higher than we ever get exposed to. Now, that's a harsh statement. That is a really harsh statement. Very provocative, obviously. And if I had gone out and told the press that, 20, 25 years ago, I wouldn't be standing here today telling you the rest of the story, I think. And I wasn't inclined, really, to, somehow I wasn't inclined to want to believe it. Because, let's face it, we in science, we think we're so objective, or we try to be so objective. We're human, and, we have to admit we come to the table with our own personal biases. We always do. And don't let anybody tell you that, science is so pure, and we do bring our baggage to the table. And it was trouble for me, to realize that what we were seeing here wasn't what I had thought, and it wasn't what my life was all about. And just to prove that point, here I am sitting here in this combine some number of years ago, obviously, being raised on a dairy farm and going out and, cutting grain for others and stuff like that. So, it was kind of a shock. What do I do with this information? What do you do with something like this? So here's what we did with it. Partly for the reason of realizing that when we looked for a mechanism, we found all kinds. Partly for that reason, it turned out, in my view, that the whole role of nutrition, as far as its effect on health is concerned, is a very comprehensive thing. It's a very dynamic thing. It involves more than one nutrient. It involves food. It involves all the chemicals in food. It involves them working together. You see, it's a more holistic kind of thing. And we shouldn't take things so much out of context, no matter how remarkable may be results like this. They're real. We did it very carefully. It got published in very best journals. We repeatedly kept getting public funding for this work. It was judged to be good research in a very competitive process. But yet, we end up with results that are pretty stark. And so we want to go beyond that question, look for something more. Here's how to expand our horizon a little bit. Maybe casein is representative of animal protein in general. And incidentally, my inference to that, without having all the results, is yes, it is. Animal protein can, in fact, in my view, is much more likely to turn on cancer development than is plant protein, just for starters. But again, that's a little bit narrow. I'm talking about just this nutrient and that nutrient. Keep that in mind just for a second. Because maybe it's just not that protein by itself. Maybe it's animal protein is representative of animal foods. Maybe that's what it is. Animal foods and plant foods have all kinds of nutrients in them. Maybe this is sort of just an indicator of plant foods and animal foods, possibly. We should think that, at least consider that possibility. Maybe it's too much animal foods and too little plant foods. See how this question is horizon is sort of expanding? Because plant foods, one could argue, at least in the time when this was being done, as being protective against cancer. animal foods were sort of coming up as possibly being associated with cancer development. Can't see that? I will tell you what it is. The next one is, the question is, I talked pretty much about experimental animal research. The question is, what about humans? So does this apply to humans? So with these questions in mind, then we had a chance to go to China to do a big human study, in addition to some other human studies. And, oh gosh, this is trouble. And so we went to China. We did a big study involving lots of humans, and we could expand our horizon. We could look at lots of different kinds of diseases, quite frankly. We could look at, all kinds of nutrient situations. We could look at patterns. We could look to see how things played out one with the other, to see how it all might relate. And in particular, I was interested, is there something here about animal foods and plant foods that might pop up and be important? And before I get to that, I want to tell you about some work that existed at that time. It's been shown many times, accepted by virtually everyone, that was the basis for some of this views that we had as far as our so-called China study is concerned. This is a plot here. You can't see the axis, comparing dietary fat intake along the bottom here versus breast cancer rates. And this is a bunch of different countries. This was published by the late Professor Ken Carroll, University of Western Ontario. It's been shown many, many times by many people. And what it basically shows is that if you put all these countries like this, and here's the United States up here, pretty high in breast cancer, very high in fat intake. And so you look at this and you see, boy, really impressive relationship between fat intake and breast cancer. The higher the fat intake, the higher breast cancer rates. Well, this story actually became, over the years, somewhat controversial, much debated. It wasn't clear how much fat really had to do with it. This actually was probably a reflection of animal food intake. And without getting into the details, what I want to tell you that is basically a reflection of animal food intake. That's the higher the animal food intake, the higher the breast cancer rates. And I think you would have to agree, that's a pretty impressive relationship. It really is. The other point about this, and that's where this line here goes, down there, is that when people move from, let's say, one risk area, one disease risk area of the world to another, in this case from a low disease risk area like Japan up here to the United States, as people move from one risk area to another risk area and they change their diet and lifestyle, they get the disease risk of the country to which they move as they change their diet and lifestyle practices. That's been shown probably 100 times in different ways. And so, and also, it infers something else. These studies have been done in people who didn't change their genes. They kept their genes the same. All they did was change their diet and lifestyle. And all of a sudden, when they change their diet and lifestyle conditions, they get the disease that goes with that diet and lifestyle condition. That's what happens. And so, as I said, it's been done many times. And now, we knew those two things. We knew that cancer, for example, a number of different cancers, heart disease, it varies a lot between different societies. We knew if you move from here to there, you might gain or lose, depending. We knew that kind of thing. So with that in mind, then we had this chance to do some work in China. And just a word about the background of that. This is a map of China, as you can see. That's very well pictured here. But it was in the early 1980s. A gentleman from China, the first senior scientist from China to come to our country when we started talking to each other, our two countries, Dr. Chen Zheng-Shi, had some distinction in China before he came here. He came to work with me at Cornell University, wanted to work in the area of diet and cancer. And while he was at my place at Cornell, we learned about the Chinese government just having completed a marvelous study of how much cancer existed in a total of 2,400 counties across all of China. It involved about 88%, I think, or something of their population. And so then they came up with these maps like this. I wish you could see it a little better, but there's color-coded, and basically what it showed is that for breast cancer, and in about a dozen other cancers, these cancers tend to be very common in some counties and not so in other counties. Big range. I mean, you could have a county here with lots of cancer and a county really nearby with very little of that kind of cancer. I mean, big differences. And the data had been ascertained to be really quite good because there were teams sent there from the United Nations and elsewhere and was concluded that their information was pretty